Thank you guys for coming. Exciting topic to talk about here since there's been a lot of requests for this kind of information over the last couple of years. And so Jeff and I are coming here to talk to you about best practices for virtualization with Exchange 2010. How many of you saw the blog post that we posted on the Exchange team blog yesterday regarding support scenarios? Okay, we'll be going into a little bit more detail on that today. So let's go ahead and get started here. I'll go over just high-level Exchange and virtualization and talk about those the support guidance at a high level, and then I'm going to hand it over to Jeff, who's on the Exchange engineering team, to go over a lot of the detail on the best practices and what it means to your organizations. So first off, I just wanted to lay the landscape. You saw Wabi talk about in the keynote yesterday about the growth of virtualization in our industry today. We see that that host servers, the physical units, there is growth, and this is IDC research data, that the physical servers are still growing, but the virtual servers are growing at a much higher rate, and you're going to see a lot higher ratio of virtual machines to hosts. And so looking at this and how it pertains to Exchange, we just see that customers are moving more toward virtualized scenarios, and from an Exchange perspective, we're looking at how we can better support those scenarios. Added onto this, looking from a maturity perspective, we only see 25% of users in this advanced virtualization scenario, and we see Exchange as one of those advanced workloads from a virtualization standpoint. But we also see that the momentum is moving there where customers do want to deploy Exchange and other advanced workloads in a virtualized environment to gain some of those efficiencies from virtualization. Now, as we look at Exchange servers specifically on why we would want to virtualize, we see the growth in customer demand for being in a virtualized environment. And so we see that where organizations have underutilized systems that they're taking advantage of higher processor core, 24 core and higher systems that you're not gonna fully utilize with Exchange. Now you can put other workloads on those systems and combine them and do some server consolidation. Also looking at lower cost for space needs and power consumption. I think they were saving some money here yesterday. It was like 114 degrees in this room. So I think that was the Atlanta's power consumption savings here. Also, from a rapid provisioning and mobile infrastructure perspective, being able to quickly deploy new virtualized host servers with very standard virtual machines that they're deploying in those machines, that Exchange may be one of those workloads on those systems and be able to bring them up fairly quickly. So as we look at our support guidance, I just want to step back and state there's been questions of, does Exchange support virtualization? And the answer is yes. We've actually supported virtualization since Exchange 2007 SP1, and that has not changed. When we released 2010, we had the same support guidance for virtualization. But we got a lot of feedback that organizations are wanting to do some of the things that we did not support, specifically combining Exchange database availability groups and hypervisor clustering or migration scenarios together on the same virtual machine. Also, the unified messaging role was not supported. So we've done a bit of work in Service Pack 1 to support the unified messaging role. So with the blog announcement that we had yesterday, we're now expanding with the requirement of Exchange 2010 SP1 to support both the DAG plus hypervisor clustering as well as the unified messaging role. And so with that, and this pertains to all hypervisors that are on the Windows SVVP program. And with that, I think now's a good time to hand over to Jeff, who's going to actually go in and talk about these specific changes and broader Exchange best practices guidance.
All right, thank you, Jim. My name is Jeff Mieleff, and I'm a program manager in the Exchange engineering group. amongst a number of roles that I play in the Exchange team, I'm the virtualization program manager for the product. And I'm going to be talking through best practices today. A couple of quick housekeeping things. I'm going to ask that you hold questions until the end. We're going to try and leave a few minutes for questions, but we also have a complete interactive session this afternoon right after lunch that is actually designed just to be Q&A from this session. So feel free to stop by and ask any questions there. Additionally, Jim and I are going to be in the booth quite a bit tomorrow if you want to stop by the Exchange team booth and ask any questions there. One other point around that, we've also released a white paper on best practices for combining Exchange with Hyper-V. And that actually is linked to on the Exchange team blog posting that Jim mentioned. So that supports a lot of the content that we're going to be talking through today and goes into some more detail around some of these concepts. So we're going to start off with some basic Exchange considerations. And this is actually a question that I've gotten asked in the booth a couple of times at TechEd here. Does virtualization actually make sense? There really is no answer that I can give for this. It really depends on customer scenarios and depends on needs, right? Historically, the Exchange product group has been pretty negative about virtualization. And we've made some fairly strong statements that we don't think customers should virtualize. That's not necessarily where we stand today. I think we recognize that a lot of our customers have already virtualized and have been running Exchange virtualized for a very long time. How many people in the room actually run Exchange in virtual machines in some form today? Okay. That's case in point. Obviously, there's many reasons to virtualize. A lot of reasons were mentioned by Jim previously: cost savings, server consolidation, et cetera. A lot of our customers, we hear virtualize Exchange because they're virtualizing everything in their data center, and they want a consistent management story across all of their infrastructure. Completely legitimate reason to virtualize Exchange. So what we're going to be talking about today, given that you've already made the decision to virtualize, is how you can do that safely with the product. So we want you to understand what those trade-offs are that come into play when you go down the path of virtualizing and how to optimize your deployment to deal with those trade-offs. So Exchange is really architected as a scale-out product. And this is really important when you think about virtualization. Right? With virtualization, what we're talking about typically is consolidating a large number of servers onto a small number of physical servers, right? Lots of VMs running on a small number of physical hosts, typically. Getting better utilization of that big hardware. We're certainly going to see more and more of that over time as what we consider commodity servers, basically your cheap two-socket servers, actually start to have a very significant number of processor cores. That's just going to continue to grow over the next few years. We certainly have seen some very interesting projections from our hardware partners around that. So scale up, we typically associate with virtualization. Scale out is where we think about architecting Exchange. So what we want you to consider here is avoiding putting all of your Exchange eggs in one basket, right? We don't want you running your entire Exchange deployment, all your CAS servers, all your mailbox servers, all your hub servers on the same physical Hyper-V host or other virtualization platform host. That doesn't make any sense. It's not good for high availability. And that's sort of the worst case scenario. We'll talk in a little more detail about some more specific scenarios where spreading out those VMs across multiple physical hosts is pretty key. Exchange doesn't know that it's virtualized. Right? There's no communication between the hypervisor and Exchange, where Exchange can say, oh, okay, I'm virtualized, I'm going to act differently because I'm running on virtual processors, on virtual NICs, using VHDs for my storage, et cetera. We have no idea that we're virtualized. So, from the perspective of deploying Exchange, there's really nothing different. That's important to be aware of from a setup perspective. I'll go into some more detail on that as well in a few minutes, but the key message there is that when you're deploying Exchange in a virtualized environment, the same considerations apply, right? You can't pre-build VHDs with Exchange and duplicate them, create lots of new VMs quickly using that method. Virtualization absolutely is not free. No matter what anybody tells you, you don't magically get resources when you virtualize. There's no additional CPU that suddenly becomes available when you click that checkbox in Windows to add the Hyper-V role. There's no additional memory that magically makes itself available to you. If anything, virtualization has a cost. And in our tests, we find that with Hyper-V, we see about 10 to 12% CPU overhead. The 12% number that's up here is sort of the worst case number, the conservative estimate that we give. When we actually do sizing, we typically use a 10% number, and we'll talk about how to apply that and how that's going to fit into the mailbox role requirements calculator later on. But keep that in mind. You're paying a cost to virtualize, and that's one of those trade-offs that I mentioned earlier. So we do still have some unsupported configurations, right? We've changed our support statement this week to support some new scenarios, but we are definitely leaving some things in the unsupported bucket. And the big ones here are snapshots. We want to ensure that Exchange as a product is always moving forward in time. So there's a couple caveats here. We're talking about production deployments of Exchange. I do a lot of test work in the lab, and I'll tell you right now, snapshots are a huge time saver for me. I have hundreds of VMs that I've built over time that are snapshotted at different periods where, pre-Exchange deployment, pre and post different configuration changes. Being able to jump back and forth in time in a test environment is phenomenal. It's a huge time saver. Highly encourage you to take advantage of that technology in your test labs where you're doing pre-production testing of Exchange or validating some sort of deployment configuration change. But in production, Exchange needs to always be moving forward in time, no going back. So we don't support snapshots. Same thing around differencing or delta disks. Those are technologies that support snapshots. We don't support differencing or delta disks in production. We also don't support oversubscription of processors with a ratio greater than 2 to 1. So what does that mean? With a hypervisor, you can actually configure a much larger number of virtual processors when you add up all the virtual processors assigned to virtual machines on a host. Then you actually have physical processors to support those workloads. We don't want you oversubscribing so much that those virtual machines don't have the resources they need to actually deliver the workload that you're asking of them. So that's the reason there. We don't support running applications on the root. By root, I mean the physical server, the root or host partition that appears on the physical Hyper-V host. We don't want you running SQL there or something else that's going to take up a whole bunch of resources. Obviously, antivirus, those types of utilities that you would run on any server in your environment, those are absolutely supported. We're talking about server applications that have big resource requirements, right? And the other key thing to be aware of, we don't support VSS backup of the root server, so the host server, when you're using pass-through disks or iSCSI disks connected to the initiator and the guest. And there's some simple reasons for that. Basically, with VSS, we need to make sure that the Exchange code that manages those VSS backups in the guests has an opportunity to actually quiesce I/O, to stop I/O to those drives when we do the VSS snapshot. And we don't have the ability to do that in these scenarios. So I want to be very clear here. Sometimes this gets misread as we don't support iSCSI disks that are connected to the initiator and the guest. It's not what we're saying. We're only talking about in the scenario where you're doing a VSS backup of the root, we don't support these. So let's talk about capacity sizing and perf for a few minutes here. So from a sizing perspective, as I mentioned previously, Exchange is not aware that it's virtualized. What this means from a sizing perspective is that you size Exchange the same way you would if you were sizing a physical deployment, right? You're going to go and figure out what you need in terms of physical resources. From a physical deployment perspective, you'd go and figure out what your I/O requirements are, what your CPU requirements are, and what your memory requirements are, and how many servers you need to meet those needs, as well as meet your high availability requirements. Nothing changes when you move to a virtual deployment. Nothing changes at all. So you're going to start with the mailbox role requirements calculator, and that's going to give you a great starting point to tell you what your I/O requirements are, and to start you down the path of figuring out your server counts. You're going to account for virtualization overhead, and we're actually building some of that into our calculator. We haven't released that change yet, but that's coming soon. And you'll actually have a drop-down in the calculator that allows you to specify whether or not you're using Hyper-V. That will account for the CPU overhead that we talked about previously, that 10 to 12%. Once you understand what those physical resources are that you need, then you need to figure out where those virtual machines are going to live. You're going to have some number of physical hosts, and you need to optimize where each one of those VMs lives normally. Obviously, they can move around a bit now that we're supporting live migration and similar technologies. But in terms of their normal location, you figure out where to place those. And once you've done that, you then need to figure out on those root servers where the VMs are going to live, what are the specific physical requirements that you need to be able to provide to meet the demand. In terms of the guest, and I'm not going to spend much time going into detail here. Feel free to look at the content that we've delivered at past tech eds or on TechNet around how to specifically size Exchange servers. But the key guidance here, always size the mailbox role first. Exchange is very dependent on the physical resources provided to the mailbox role. Exchange is a big database when it comes right down to it, right? We're a big database that has various client access technologies that go and access the data in the database, but we're very dependent on the I/O behind that mailbox role, being able to provide quick access to the data in that database containing terabytes, potentially petabytes of email data. So make sure you get the mailbox role right from there. A lot of our guidance actually is around server or CPU ratios between the mailbox role and the other roles. So if you've sized mailbox, you're on the right track to sizing the other roles. And then around virtualization, when you're sizing for a new deployment, don't oversubscribe or overallocate resources. Right? We don't want you to build your virtual deployment with the assumption that you're not actually going to use the resources that you're sizing for. When you size Exchange, you're sizing for that peak workload that you want to be able to deliver when your clients demand it. And if you're oversubscribing or overallocating resources at this point, you're basically saying, well, I know I'm going to need those resources eventually, but I'm also going to make the conscious decision to not have them available when I need them. Doesn't make a lot of sense, so we really want you to avoid doing that. There are scenarios where it makes sense to oversubscribe or overallocate, particularly when you're consolidating servers that you already have deployed, maybe doing physical to virtual consolidation using the P2V technology that's in Virtual Machine Manager. Very cool technology, by the way. It can make sense there. But in general, we don't want you to oversubscribe or overallocate. And then network is quite key in a virtual deployment. So with Exchange, we'll typically provide a little bit of networking guidance around number of NICs and isolating replication traffic and MAPI traffic on your mailbox servers. But we don't go into a lot of detail. When you start consolidating lots of virtual machines, lots of Exchange virtual machines on physical Hyper-V or other virtualization hosts, the network configuration actually starts to become kind of interesting. Because you need to make sure that you're actually able to not only provide isolation for different types of traffic that need to be isolated, your replication traffic, your client access traffic, et cetera, you need to be able to provide the right amount of bandwidth. So where we might have said, yeah, Exchange isn't going to need more than a gigabit NIC on that particular role. Well, That's fine for a single physical host, but now that you're combining a whole bunch of those physical hosts, sorry, a whole bunch of those virtual hosts onto a physical host, that single gigabit NIC that's now being shared by all of those machines may not be enough. So keep that in mind. So as Jim mentioned, we're now supporting the unified messaging role. Out of curiosity, how many people in the room actually think they would want to virtualize unified messaging? Is this useful? Somewhat? OK, good. It's good to see. So we are requiring Exchange 2010 SP1 or later for this. There are some changes that we made from a coding perspective in SP1 that enable this to work well. If you follow the guidelines here in terms of sizing, run it on Exchange 2010 RTM, you're likely going to have a very poor experience with voice quality. Don't want you to have that experience. So 2010 SP1 or greater. We are going to require a minimum of 4 virtual processors. On Hyper-V, that's also going to be your maximum at the moment, because 4 virtual processors is the max per VM. And then from a sizing perspective, we just ask that you follow the normal sizing guidelines for memory for the role. We don't want you to oversubscribe here at all. We actually need to be able to use those 4 virtual processors. And what we've seen in our lab tests is that if we don't have full access to those processing resources when we need them, you're going to have a really poor voice quality coming from that role. And in tests that we've done in the lab, we've shown that we can easily handle 40 concurrent calls with a 4 virtual proc, 16 gig virtual machine when we're actually using voicemail preview. It's that Exchange 2010 technology that transcribes voicemail messages and ensures that I don't have to actually use my phone to listen to voicemail anymore. And get some entertainment about the way things get transcribed. There's usually at least some humor in there. Or 65 concurrent calls without VM preview. So from a performance perspective, pretty good and pretty well aligned with what we see on physical servers as well. So from a root server sizing perspective, this guidance doesn't really change from what we've talked about previously with 2007 and 2010. You need to make sure that from a storage perspective on your root servers, that you have space, obviously, for the OS and your hypervisor components. And from a connectivity to guest VMs perspective, one mistake that we see a lot of our customers making, I know that none of the Exchange experts in this room would make this mistake, but we've seen people not consider high availability of the path to the storage between the root servers and whatever is backing that storage. We know that a lot of customers that virtualize use some sort of shared storage system, whether it's a SAN with fiber channel connectivity, iSCSI connectivity, whatever it is. Think about high availability of that path. That's really going to be one of the keys to having a great user experience with Exchange. You want to make sure that if one of those links goes down, your entire virtualized deployment doesn't go down. And then as I mentioned already, network sizing, very critical. So once we start talking about live migration or vMotion or other similar technologies, the bandwidth required to actually migrate those machines, those virtual machines between physical hosts, becomes very key. So that's an additional network requirement that we didn't have before. Need to consider that. Additionally, the heart beating associated with the clustering of those root servers also becomes quite key. Cluster shared volumes also require some network bandwidth between those root servers for redirected I/O. So start to have a lot more requirements for network here. And we can talk through some of the details in the Chalk Talk later. We'll actually be delivering that with Hewlett-Packard, one of our hardware partners, who helped us out quite a bit with some of the testing that we did on this around this support stance change. And they can talk about how specifically the hardware was configured that we used for testing from a networking perspective. So from a root server perspective around CPU, obviously we need to account, as I mentioned, for all the requirements of the VMs that are running. Ideally, we're not oversubscribing at all. I mentioned the 10 to 12% for Hyper-V. That actually doesn't follow for every hypervisor. So we support all the hypervisors that are participating within the server virtualization validation program. What we recommend is that you actually follow the guidance from your hypervisor vendor. If that's not Hyper-V, it's going to be a little bit different, most likely, than that 10 to 12% we mentioned. So work with your hypervisor vendor, understand what their best practices are for sizing, and apply those numbers to your deployment. From a memory perspective, same thing applies. We don't want to see you over-allocate. We want to see you size your VMs for what their memory requirements are and actually make that memory available full-time to your Exchange machines. On the root server, there are some basic requirements for getting a VM up and running. And I provide the formula for Hyper-V here that's actually part of the Windows Server 2008 R2 perf tuning white paper. But the same thing applies around talking to your hypervisor vendor, following their best practices. So for virtual processors, another mistake that we've actually seen a fair amount of. And once again, I know that all of the Exchange experts in the room here would never do this. But we have seen a number of customers deploy 4 one virtual CPU Exchange servers rather than deploying one server with 4 virtual CPUs. And I think the reason for this is that there's some guidance out in the world somewhere that there's some overhead associated with, from a scalability perspective, with a cost for higher numbers of virtual CPUs. And this guidance makes sense if you're virtualizing applications that can't actually take advantage of multiple CPUs. Those types of applications, you want to virtualize on a single virtual CPU VM. You're not going to be able to use that extra hardware, and the OS is actually going to do some extra work to deal with those extra CPUs. Exchange, very much optimized to take advantage of lots and lots of CPUs. So build out your Exchange VMs to have as many virtual CPUs as possible. That's the basic message here. We also want to make sure that you understand that if you're running hyperthreading, a hyperthreaded CPU is not a real CPU, not a real CPU core. So when you're making these calculations, keep in mind that hyperthreading is going to add a little bit of additional throughput. When we deploy Exchange on physical hosts these days, we typically see 30% throughput increase if you hyperthread. And there are some caveats when you wouldn't necessarily want to do that. I'm not going to go into here, but just keep in mind the CPU count when you hyperthread, if you go into Task Manager, it's not necessarily the number you should be using for this. Use the physical CPU core count. So around server deployment, I briefly touched on the idea that where the VMs live, in terms of which physical server they live on, is important for high availability. We don't want you, when you're building out a DAG, to put multiple copies of the same database on the same physical host. Right? So what that means is that we want to make sure that from a high availability perspective, if you lose the physical host, you're not going to lose multiple Exchange database copies at the same time. It really kind of defeats the purpose of a database availability group. You want those copies on as many physical servers as you can get them on. Very key. Unlike the scenario where you actually deploy multi-role or all-in-one, where you have all Exchange roles running on the same physical host, where Exchange actually is aware that those roles are co-located on a machine. When you're running in a virtualized world, if you're running a mailbox server, a CAS server, and a hub server, all on the same machine but virtualized in different VMs, Exchange has no idea that that's the case. We have no visibility into that. And what that means is that we can't actually take advantage of one of the cool little tricks that we have up our sleeve when we're running multi-role to prevent data loss, or the potential for data loss, when we're actually handling outbound mail. So in that multi-role scenario, we realize that you're running hub and mailbox on the same physical machine. And we won't actually use the local hub server for submission when you send outbound mail. If we were using that local hub server for handling that outbound submitted mail, and the machine went down, you lost that storage, there's a potential there for some data loss. So we actually, in that scenario, will go and prefer another hub server to handle that submission. And even if you're sending to a user that's on the local mailbox server, we'll come back in and do the delivery to that local server. In a virtual deployment, we can't do that because we don't know that we're on the same physical server. So we recommend separating mailbox servers and hub servers on separate physical hosts wherever you possibly can. It's a small window of potential for data loss, but still, it's key to be aware that it's pretty easy to avoid that scenario. And then we want you to ensure that your peak workload that you're sizing for, worst case scenario that we always ask you to size for, you can handle in your default locations for those virtual machines. So realizing that you can move things around with live migration, wherever those VMs normally live, you need to be able to handle that peak workload and understand the risk associated with moving those VMs to other locations temporarily for maintenance. If something goes wrong while they're in one of those alternate locations, be aware of what that risk is, and be aware that you can handle it with minimum impact to your client workloads when that occurs. So around storage, as I mentioned, Exchange is a database, right? Very heavily dependent on access to storage, quick access to storage, low latency, high bandwidth connectivity to whatever storage is behind Exchange. Many options here for how you can actually make storage available to Exchange in a virtual world. We support VHDs, though we only support fixed VHDs for storing Exchange data. There's actually a performance reason for that. We support fiber channel connectivity, same as we always have for connecting to SANs. iSCSI, fiber channel over Ethernet, similar technology over commodity network hardware. And we also support DAS. You can virtualize with DAS. Can't really live migrate with DAS. Can't really do any sort of root level failover clustering with DAS. You still need to have some sort of shared connectivity to your storage to be able to enable those technologies. But it's important to be aware that you can deploy Exchange on some of this low-cost, large storage that we've been talking about with Exchange 2010 and actually still virtualize. So when you think about the storage technology that you're going to use, the key message from the Exchange team is look for options that provide large mailboxes at low cost, right? That's one of the key value propositions of the Exchange 2010 product. And there's ways to do that in a virtual world. I expect that we're going to be talking a lot more about creative ways to do that and take advantage of live migration and some of these other very cool technologies in the near future. But around DAS, you do still have options there. Keep that in mind. So we recommend, from a storage configuration perspective, Exchange storage. So the storage that's actually holding Exchange data, your mailbox databases, log files, hub queues, et cetera. We recommend that be on separate storage from the guest OS VHDs. Primarily a performance reason there. As I mentioned, Exchange storage needs to be on fixed VHDs if you're using VHD technology. Can't use dynamically expanding VHDs. SCSI pass-through drives, where you're actually taking a SCSI drive that's presented to the physical host and passing it through to one of the virtual machines on that physical host, or iSCSI. And you can connect from an iSCSI perspective, either from the root and actually pass through the drive, or run the iSCSI initiator in the guest. Either one works. From a performance perspective, we recommend SCSI pass-through. Absolutely. It's kind of a generic recommendation, and there are some scenarios where that recommendation doesn't apply anymore, and one of them is around live migration. So from a test perspective, when we've, over the last few months as we've been looking at live migration and database availability groups in our labs, one of the areas where we've run into some issues is with using SCSI pass-through, presentation of disks, and live migration. So as you migrate VMs between machines, the storage that those virtual machines is accessing needs to actually be failed over or kind of remapped between those machines. The time that it takes to do that with SCSI pass-through disks is actually significantly longer than if you use cluster shared volumes. And cluster shared volumes use virtual VHDs, virtual hard disks, on a shared storage LUN with some pretty cool mapping technology behind the scenes that the Hyper-V and Windows failover clustering teams have put together. It's actually, in what we've seen from a test perspective, about twice as fast to fail over with cluster shared volumes. So we recommend if you're using live migration, use CSV. You'll get a much better experience. And ideally, you won't actually have to go and modify any of the default settings from a clustering perspective within the Exchange product. We found that with pass-through drives, we would actually see the blackout period, where from a live migration perspective, the virtual machine was actually inaccessible. We would see that take long enough that the Exchange virtual machine would get evicted from the DAG. Cluster heartbeats would be failing for a long enough period that the cluster node would get evicted from the DAG, come back online, get re-recognized, and things would eventually stabilize, but not an optimal experience from an Exchange perspective. So we actually found that we had to raise those timeouts in order to accommodate that scenario. As soon as we moved to cluster shared volumes, no problem. All the defaults work, everything's happy. And in talking to some folks in the booth yesterday, actually, who've been doing this in production for quite some time in an unsupported state, they found the same thing. Cluster shared volumes work great. So we recommend that if you're going to go down the live migration path. Around iSCSI, we do recommend that you follow all the standard best practices for iSCSI deployment. So use jumbo frames. Use the offload technologies that are available on some of the modern network interface cards. Use dedicated NICs for your iSCSI connectivity. Make sure that you have that performance available between your host and your storage. And then one of the key changes that we keep getting questions on that we're not changing as part of the support statement update is around Exchange storage, needing to be block level storage. Right? We get a lot of questions on this. So the Exchange database technology, JET, expects that the storage that's underneath it can handle block level updates. Basically, we're using APIs in Windows to make changes to data on disk that assumes that data is presented to us in a block level format, not a file level format. So Exchange, regardless of how it's being deployed, doesn't support NAS, network attached storage, any sort of file level presentation of storage. We always require block level storage. We're not making any changes about that requirement here. So keep that in mind. And this includes any sort of technology that the hypervisor provides that makes a NAS storage volume appear as a block level storage volume. That's still not supported by Microsoft for deployment with the Exchange product. So from an Exchange VM deployment perspective, once again, Exchange has no idea that it's virtualized. So just as you can't actually pre-deploy Exchange on a physical host and just go insert that into some other Exchange forest and have it come up and work, right? We store configuration information in the Active Directory, and that's instantiated or created when we run setup. Nothing really changes in that scenario with virtual machines. So when you're deploying new Exchange virtual machines, you can't pre-deploy Exchange, copy that VHD, and grow your Exchange deployment that way. So what we recommend doing here is actually building a VM that's sort of your template VM that has the Exchange install bits on it. Makes it quick and easy to get to the install bits. You can actually you could write some scripts that actually automate the process of building out Exchange, potentially up to the point of having each VM figure out what roles it's supposed to be, maybe based on the host name that gets configured as Exchange is brought up, as Windows is brought up on the host. And you can also, pre-patch, install all the prereqs, do everything that potentially takes a fair amount of time when you're deploying Exchange. Get all that done up front, and then use that as your template to move around. So around high availability and virtual machine migration, which are two totally different things, to be clear. I wanted to start off with a couple of quick definitions just so we're all talking about the same things. There's a lot of confusion around terminology in this area. And that, I think, has led to a lot of the tough conversations that we've had over the last few years with the Exchange product and different virtualization technologies in this area. So I'm going to try and clear up as much of the confusion as I can around terminology, make sure that we're all on the same page here. So from an Exchange perspective, when we think about high availability, what we're talking about is application-driven, automated switchover, such that from a client perspective, the client always has access to the data that they expect to be able to access, right? Regardless of what happened on the server, whether the server went down, whether a database failed, whether a network interface went down, whatever happened, the application realized that there was a problem, it addressed the problem, and everything is still up and running. That's high availability to us. And we have great functionality in the 2010 product with database availability groups to make that happen, right? Around disaster recovery, that's more of a manual process. So that's, I lost a site. I now need to make a manual decision to move over to my disaster recovery site and bring that up, potentially with some temporary data loss. Maybe I'm going to come up with dial tone databases and bring my data over when I can get it there. Or maybe I have a little bit of a lag that I need to pick up over time. So that's more of a manual process as opposed to the automated switchover process that you get with high availability. Now, I haven't mentioned anything at all related to live migration or similar technologies. They don't really fall into this bucket. Really a totally different bucket all on their own. So 2010 high availability, this is what you're running in your guest VMs. You have a database availability group of multiple mailbox VMs that are providing high availability with multiple mailbox copies that are replicating around. All of the same features that are in a database availability group on physical hardware apply in the virtual world as well. You can still stretch your DAG across subnets, across sites, take full advantage of all that functionality that you get with DAG. And you get all of this protection from database failures, server failures, network failures, et cetera. This includes failures that occur at the host level, right? So if your Hyper-V host dies, your physical Hyper-V host dies, assuming that you haven't put all of your mailbox VMs on the same physical server, because you're not going to do that, right? Assuming that's not the case, your other mailbox VMs will pick up the fact that that mailbox VM on the dead Hyper-V host went away, and they'll take over that workload. So you get that protection built into Exchange. There's nothing that we've talked about so far that has anything to do with live migration or root level failover clustering. So now's where we start talking about that other bucket. So host-based failover clustering. What we mean here is clustering that happens across the root servers where you're running your virtual machines. So no configuration related to Exchange. What we're talking about is configuration related to virtual machines and how virtual machines respond to failures that are occurring at the host level, right? And this can happen in response to some sort of failure on a host where we want to respond in an automated way and bring up the VMs that we're running on a host on another physical host, which is now supported. Or it can happen from a planned perspective. And that's not really what we would consider failover clustering. That's more of a migration. It's where we start talking about live migration. Live migration is around planned movement of VMs from one host to another. It's not happening in an automated way. You're physically, as an administrator, making a choice and going and using your mouse or your keyboard to say, move this VM from one place to another, not high availability technology. So from our perspective, host-based failover clustering doesn't know what's going on with Exchange. It has no ability to go down into the depths of Exchange and say, hey, are you actually up and running? Are you moving mail? Can users actually access OA? Host-based failover clustering doesn't have any visibility into that whatsoever. All it knows is that the OS is up and running on a VM and appears to be doing work. If the VM blue screens or there's some failure of that type, host-based failover clustering can respond to that in an automated way. And that potentially adds some additional high availability for you, though keep in mind that from an Exchange perspective, you're already going to be protected from that with DAGs, right? So I'm going to save questions until the end. All right, so I'm going to move on. So with virtual machine migration, primary reasons for using this technology, live migration in the case of Hyper-V, really around maintenance. So the ability to patch your host servers. You can now do this without actually impacting your virtual workloads, right? You can move those active virtual machines from one physical host to another in such a way that you don't impact client access. Do whatever sort of maintenance you need on that physical host, reboot it, take it down for memory upgrades, whatever, and bring it back online, move those VMs back. Your clients know nothing, right? Nothing happened from their perspective. That's very cool technology that's enabled by live migration. Rebalancing workloads is actually another really interesting example of how you can take advantage of this technology. So the idea here is that maybe you have multiple workloads running on your physical hosts. So you've got Exchange, you've got some other workload, maybe a database application, maybe some sort of line of business application. And you find that maybe Exchange is hogging all the resources on the box. And so your line of business application is suffering from a performance perspective. And you've got this physical host over here, this Hyper-V physical host, that's not doing anything at the moment. With live migration, you just click on that VM, move it to the machine that's not, the physical machine that's not really doing anything, and you've solved the problem. Now you have additional physical resources for that VM, and Exchange can go on its merry way, hogging resources on the original host, and your line of business application is now running much better. And then the opposite also applies. So we see a lot of customers very interested in this concept of consolidating VMs for off-peak periods. So you could potentially even automate this to the point that on a weekend, let's say you have half your CAS workload on a weekend. You could move CAS VMs from their normal locations where they're distributed across a large number of physical hosts to some smaller number of consolidated physical hosts and actually power off those physical servers that you're not using anymore. Potential for some pretty significant power savings. You always have those physical resources available to bring up fairly quickly if you need them. But you can take advantage of some savings there when they're not normally being used. So when you're actually using this technology, this is based on some of the testing that we've done and some of the feedback that we've gotten from customers. You need to minimize the actual outage time that occurs from a live migration perspective. So there's some terminology that we use in the engineering teams when we're thinking about this. There's the concept of kind of a brownout time and a blackout time. So when live migration is actually moving a machine, it needs to move all of the memory associated with the virtual machine between physical hosts. And it does that over a dedicated network link, the live migration network. And the brownout period is that time where you've specified that you want to move the machine. It's doing that initial pass of moving memory. And that can take a fairly significant amount of time, depending on how much bandwidth you have in that on that network link. The blackout time is really this outage time. So that's when that virtual machine actually is inaccessible to clients. And ideally, that's a matter of a few seconds. We've certainly seen that we can migrate mailbox servers under load, under fairly significant load, in a matter of less than 5 seconds for this outage period or this blackout period. You want to minimize that as much as possible. One negative thing that can occur I already mentioned, and that's the cluster heartbeat timeout being exceeded and the node getting evicted from the DAG. Need to avoid that if at all possible. One of the confusing things that's in the support statement that I think we're going to need to go clarify pretty quickly, because I've already gotten a very significant number of questions on this, and it's only been out there for less than 24 hours, is around the terminology in there related to quick migration and saving state and migrating. So by default, when you deploy virtual machines on Windows with Hyper-V, and you've clustered those virtual machines so that you can now take advantage of live migration and also take advantage of Windows failover clustering. If you go in and rather than specify that you want to live migrate a machine between nodes, if you go and say that you want to move that VM resource between nodes, by default, it's going to do a quick migration. What that means is that it's actually going to save sort of a point-in-time snapshot of that virtual machine to disk, which takes a fair amount of time, moves the resource to the other physical host, brings all that state data off of disk into memory, and brings up the machine. Takes a fair amount of time, and it's totally unsupported. We don't support quick migration of Exchange virtual machines. We never have. We don't intend to, because it's basically taking a snapshot, and for the reasons I described earlier, we don't want snapshots of virtual machines in production. So there's a way within Hyper-V to go in and say, when you move this machine, other than live migration, when you move this machine resource, I actually want you to shut the VM down before you move it, and then bring it up on the other machine. That's the supported way to do this. And so we want you to always migrate machines either live migration, similar technology, or completely shut down. So coexistence with other workloads. This is where we bring up the term private cloud. And private cloud has a number of different meanings. I'm going to use my definition here, and hopefully that'll align with your definition as well. We'll see. From an Exchange deployment perspective, we certainly support deploying in private clouds, right? What is a private cloud from this perspective? What we're talking about is a collection of physical resources that are available for use from a virtualization perspective on demand. And what we want to ensure is that you're applying the same best practices we've talked about in terms of how to deploy Exchange on VMs in a private cloud world. So in the same way that you might go and order physical hardware to deploy Exchange, what we want you to think about from a private cloud world is procuring virtual resources to deploy Exchange on. So there's a lot of talk with private cloud around dynamic allocation of resources and dynamic adjustment of resources to optimize resource utilization. We don't want you to do that with Exchange. We want Exchange to have dedicated resources to provide the best client experience it can possibly provide to end users. And so we want you to think of a private cloud as pre-built infrastructure. You've already got the physical hardware there. All you're doing is carving off chunks of it for Exchange. And those chunks need to be as dedicated as possible to Exchange. That's the key message around our private cloud guidance for the Exchange product, right? You're just carving off specific chunks of that private cloud for Exchange to take advantage of in a non-dynamic way. So around resource allocation, balancing of resources, these sorts of technologies, Hyper-V has dynamic memory technology. A number of other hypervisors have similar, not exactly the same, but similar technology for dynamically adjusting memory allocations to virtual machines. Exchange does not play well in that world. It expects that when it starts up, it sees a certain amount of memory available to it. And if that memory changes, all that can really happen from an Exchange perspective is badness. If you go hot add memory to an Exchange server, we don't really know how to deal with that in a great way. So when memory is taken away from us, we certainly respond to that. And when you think about an Exchange mailbox server and how much memory it uses, which is basically all the memory on the box, we're doing that for a reason. We're doing that to minimize disk I/O. And from a dynamic memory perspective, if you go and force us to page out all of that memory, that means that all that memory that we were using to minimize disk I/O no longer available to us, and your I/O is going to shoot through the roof. You thought that 70% reduction in I/O between 2003 and 2007 and that another 70% between 2007 and 2010 was great. It all just got wiped out. And we're probably even worse than 2003 all of a sudden, right? So we want to make sure that you're actually disabling those auto-tuning features. They're not going to add benefit to Exchange. Some of the hypervisors provide storage tuning, rebalancing type technologies. Same thing. We want to make sure that Exchange has dedicated access to the storage resources that you've sized for. So guidance here is disable those. Don't take advantage of them for Exchange. There's certainly types of applications that respond very well to dynamic tuning and allow you to get better consolidation rates. And you should absolutely utilize these technologies for those types of applications. So around tools and resources, Jim mentioned the server virtualization validation program at the beginning of the talk. This is our key support program for other hypervisors other than Hyper-V. So Exchange supports any hypervisor that is participating in this program. So if you're running a hypervisor and you want to understand if Exchange is supported with it, this is where you go to find out. We've also produced some pre-built, pre-tested solutions running Exchange 2010 on Hyper-V. And a lot of this work was done through what we call the Exchange Tested Solutions program, where we built out, in cooperation with some hardware partners, full end-to-end solutions built with hardware the way a real customer would deploy it, which is not necessarily the way we always deploy in our internal test labs, where we're optimizing for various test scenarios. These are from the hardware partner's perspective, our consulting field's perspective, and our perspective, deployed in the way our customers would with our best practices in mind. And in addition to actually just running through the deployment and ensuring that everything works, these were actually run with load for a period of time. They were validated with jet stress from a storage perspective. They were validated with load gen to ensure that they could actually support client load across the board. And we created documentation around each one of these solutions that describes each specific piece of hardware that was deployed, how they were all connected together, and how they responded to those tests. So you can see the jet stress results, you can see the load gen results, and you can see the workload that they were designed for, as well as the design decisions. This is actually the part of Exchange Tested Solutions that I think is probably the most exciting and the most key. We actually walk through, step by step, why we made the decisions that we did, so you can learn from our thought process as we went through those choices. Obviously, not everything we do here will apply to all the scenarios that you're dealing with, but by exposing those questions that we went through, ideally you can get an idea of how to apply them to your own scenarios. From a support perspective, we have one doc on the web, one document on the web that is the key source of support guidance for the Exchange 2010 product with virtualization. And that's a link to just the standard TechNet web page that describes all of our hardware support policies, what the minimum amount of RAM is that's required to deploy Exchange, et cetera. There's a hardware virtualization section at the end of that walks through step by step all the things we do support, all the things we don't support. We update that relatively frequently in response to feedback that we get from everyone in the room, from our consulting field, from our support organization, and from our customers. So keep an eye on that. When we make major changes, we'll obviously announce them like we did yesterday through the Exchange team blog as well. The Server Virtualization Validation Program has a support policy wizard that allows you to select your hypervisor and select the application that you're running on, and it'll tell you whether or not you're in a supported state and any caveats that are associated with that combination. We do find sometimes there's a little bit of lag in getting that updated, so we recommend validating that the recommendation that it gives you is also consistent with the TechNet guidance. We're big fans of the mailbox role requirement calculator. And Ross Smith down here, sitting down here up front, is working on an update to it that, as I mentioned, will include a drop-down option for whether or not you're virtualizing. And that'll automatically apply the Hyper-V CPU sizing guidance to the recommendations that the calculator makes. If you're not using Hyper-V, you'll have a little bit extra work to do. There's a field within the calculator that allows you to apply a percentage multiplier basically to the CPU guidance. And you'll need to figure out what that recommendation is from your hypervisor vendor. But if you're using Hyper-V, just click the drop-down, you get your recommendation. Problem solved. So in summary, Jim went over Exchange and virtualization, where we see the market moving over time. We talked through the updated support guidance. Just to be 100% clear, DAG and live migration, absolutely supported as of yesterday. Unified messaging role, absolutely supported as of yesterday. We're very excited about that and look forward to seeing customers deploying that and enabling all kinds of interesting new scenarios with those technologies. So around best practices, we walked through our key messages there. I think the biggest message that I would reiterate, don't oversubscribe, right? When you're sizing Exchange on a virtualized deployment, size for physical, make sure you've got those resources available in that virtual world, and you'll be good to go. And then we provided lots of details on tools and resources. So related content, as I mentioned, we have an interactive session this afternoon. I believe it's at 1:30, where we will be jointly presenting with Hewlett-Packard, who partnered with us on the testing for this area, to basically answer all of your questions. That's really all it is a Q&A session for anything you want to talk about related to Exchange and virtualization. Look forward to seeing you there. And we will definitely be at the Exchange booth as well if you have any questions.